There are times when vectors are used to represent or model forces acting on different objects, or to model forces or movements of heat or temperature uh, in real life applications or in mathematical models of applications, where we want to know if vectors are parallel, if they have the same direction, or if vectors are orthogonal or perpendicular to one another. And the way that we would get at this information is by knowing the angle in between these vectors. So specifically, in order to tell if vectors are parallel to one another, the angles that we would expect to see would be either 0 degrees or 180 degrees. If it's 0 degrees, that means that the vectors are parallel and that they're pointing in the same direction. So to look at a little picture of this, say here, this is my vector V. So let's call this vector V here. And now, if we had a situation where the angle in between two vectors, so here's my vector V, and now here I have an angle here, and this is my vector W. So these vectors are pointing, they're parallel, and they are in the same direction here. I've shown a space so you could see distinctly the two vectors, but you can see the degree of the angle in between these two vectors is 0. So when the angle in between two vectors is 0, that means that they are parallel and they are moving in the same direction. Now, we might have a scenario. So let me get my vector V going again here. I'll keep V the same. So here is vector V, similar to the last example. But now, vector W, starting at the same, assuming it's starting at 0, 0 again, starting at the origin, my vector V in this case is going like this. This is the direction of W. So in this situation, we can see that they are parallel. They have the same slope. They are parallel. However, this is going in the opposite direction. So the angle here in between these two, this theta here, would be 180 degrees. So if you get an angle between the two vectors is 0, that means that they are parallel in the same direction. And if you get the angle of 180 degrees, they're parallel but in the opposite direction. So what is this going to look like when we use our cosine to get this? Well, in this case, we're going to get that the cosine of theta is equal to 1. And we know that the angle that has a cosine of 1 is 0 degrees. So in this case, theta is 0 degrees. We also know that we can get it at 360, but we're going to be just looking at 0. We're not going to consider 360 degrees. That just says you made a complete cycle to get back there. For our purposes, we don't need to be more complicated. So we're just going to use the 0 degrees. In this instance, what it's going to look like is we're going to have that the cosine of theta is equal to -1. So when we are using our dot product formula, and if we see that when we make our substitutions and get our information, we're looking at the cosine theta is -1. In this case, theta would be 180 degrees, or pi, let's not forget our radian measure. And when we get that angle of 180 degrees, it's going to be parallel, but going in the opposite direction. So now let's take a look and consider, what about the possibility of vectors being orthogonal or perpendicular? They mean the same thing. In the world of vectors, rather than describing them using this word perpendicular, we're going to use the word orthogonal. I can't tell you why, I just know that's how it is. And we know that for two lines to be orthogonal, or two vectors to be orthogonal, the angle in between, by definition, has to be 90 degrees, or pi over 2. So when we use our formula from back up here, we can see that to get a cosine of 0, that says our dot product is going to be 0. Down here, these are magnitudes, so we're not going to get 0 magnitudes unless we have the 0 vector. So we're not going to talk about the 0 vector now. We're talking about non-zero vectors. So there will always be magnitudes, and there will always be a denominator that's positive. It's the numerator that's going to determine is the cosine 0 or not. So when we're looking to see if two vectors are orthogonal or perpendicular, it's the numerator, which has the dot product, that we are going to be focusing on. And that's what this statement says here, that two, again, non-zero vectors are going to be orthogonal if and only if that numerator, if that dot product is 0. And here it goes on to talk about the 0 vector, that because the 0 vector, the dot product with the 0 vector, the dot product of the 0 vector with any vector is 0, the 0 vector is going to be orthogonal by definition to every vector. So we know these 0 vectors will be orthogonal to anything, so we don't have to use any formulas to figure it out. For all other non-zero vectors, we're going to find the dot product between the two vectors and see if that is 0 or not. If it's not 0, we can go on to determine what angle it would be. So just to rewrite my formula, the cosine of the angle theta in between these two is going to be the dot W. Now in this case, I'm using U and V, but I'm just going to use the general formula of V. So this technically would be U, and then the magnitude of V and the magnitude of W. Probably should have used V and U. I'm just going to use, well, this is the beauty of markers. I can change it. So I'll have this be V and U, and then make that U down there so it fits better with our example. So again, we could find the magnitudes of these, but we know it's going to be some number down here, and that's not really what we need, because at this point we want to see what this dot product is, because if this is 0, we can stop. We don't have to find these magnitudes. If this isn't 0, then we're going to have to continue to find the magnitudes to see what the theta will be. So for our dot product here, V dot U, this is going to be 2 times 6 plus 3 times -4. 2 times 6 is 12, 3 times -4 is -12, equals 0. So the dot product is 0. So we can stop here because we know this will be, our angle will be 90 degrees, but just to sort of prove it to you, here we said this is the cosine. So the cosine of theta is going to be 0 because this is 0. So 0 divided by anything is just 0. So the cosine of our angle is 0, and we know that the angle that has a cosine of 0, theta, is going to be 90 degrees or pi over 2. So therefore, because the angle in between these two vectors is our 90 degrees or pi over 2, these vectors are orthogonal. So we can stop here. If this wasn't 0, if this was any other number other than 0, we would proceed to divide by our magnitudes to see if we got, well, in the cases of parallel or perpendicular, if we got 1 or -1, we would know that they were parallel. And if it was any other number, we would proceed to do inverse cos to find what that angle is. So just to finish up with this section, I do want to show you, I randomly put it on this section of the notes, but what I've done here is I have sketched in our vectors here. So this here, this is our 1, 2. So this here is vector u. And then this vector down here is our vector v. So this is our 6, 1, 2, 3, 4, 5, 6, -4. So this is here our vector v. So here is a graphic representation of the two vectors we just determined were orthogonal or did have that 90-degree angle in between them. So here are the two vectors, and this angle here, there is our theta, and we determined that was 90 degrees. If I rotate this a little differently to help you see that this does indeed, I mean, I don't have a protractor to measure it, but it does indeed look very close to a 90-degree angle.